everyone. So here this is a question which is asked in TIFR-GS 2017. Here the question says that suppose f is a continuously differentiable function on R such that f of x converges to 1 and f dash of x converges to b as x tends to infinity. Then the value of b equals to 1. So here we basically have to identify whether the given statement is a true statement or a false statement. Now, let us go back to the question again. That here it is given that the function f is a continuously differentiable function. So, what do we mean by a function being continuously differentiable? It says that the function is differentiable. At the same time, we also have the derivative of the function f dash. This is continuous on the set of all real numbers. And again, it is told that the function f of x converges to 1 and the derivative converges to b as x tends to infinity. Now here is the value of b equals to 1. This is our question. Now, if I see the function f of x converges to 1 as x tends to infinity, so using the epsilon delta definition, we can say that for all epsilon greater than 0, modulus of f of x minus 1 is less than epsilon for all some x greater than equals to m. So the function f of x is converging to 1 when x is tending to infinity. Means however large you take the value of x, this is going to hold true. Now from here, and along with that, we also have that the derivative of the function is continuous. Means if I take any element p belonging to the set of all real numbers, I have mod of f dash of x minus of f dash of p. This is less than epsilon for some delta positive. And how does it behave? Whenever we have mod x minus p to be less than delta. So this is a definition of continuity of f dash of x. We have used this. We have used this condition also. Now, from here, can we say that mod f dash of x minus 1 is less than epsilon for all x greater than equals to some natural number m naught? So can we say this using these two statements? So hardly we can find out any relation. So some way the statement seems to be false. So if the statement seems to be false, we need to have a proper counter example for it. So here a very basic counter example which comes to our mind here is f of x is equals to e power minus x plus 1. Now here, if you see that limit extending to infinity f of x, this is equals to 1. That is f of x converges to 1 as x tends to infinity. Now, if we see f dash of x, the derivative of the function f is minus e power minus x. Now here, if I take limit extending to infinity of f dash of x, this is nothing but equals to 0, which is the value of b. So here we are getting the value of b to be equal to 0. So is it always necessary that b is equals to 1? So here the answer to that is a no. And we have a counter example in front of us. So that's all about this question. So here, of course, this the truth value is 0. That is, the statement is a false statement. I think the solution is understandable to everyone and it was helpful. Thank you. Thank you, everyone.